Welcome back to my channel, Knowledge Spread by Sir Boots. It's been a long while that I have not made a vlog here, but I am back again. So this time I will be talking about the normal distribution. Normal distribution is for continuous random variable. We are done with the discrete probability distribution, and that talks about probability. And this one is for continuous random variable. The normal distribution discuss about the primarily on the normal curve, the normal curve below which under which there is an area, and that is the counterpart for the probability in the discrete probability distribution. So we have the properties of the normal curve. So, but before that, we have a normal distribution is a distribution of a continuous random variable whose graph is bell-shaped curve called normal curve, and the equation of the normal curve with mean mu and standard deviation O is y equals 1 over O standard deviation, the square root times the square root of 2 pi times e raised to 1/2 times x minus mu over O raised to square, where mu is a mean and O is a standard deviation. That is for x greater than x is greater than negative infinity, and x is less than positive infinity. Okay, and where the values of pi are 3.1416 and e is 2.71828. Okay, the appearance of the bell-shaped curve depends on the two values, the mean mu and the standard deviation O of the distribution. Okay, the size of the spread of the normal curve depends on the value of standard deviation. The larger the value of the standard deviation, the wider is the spread of the normal curve. The spread, I mean the opening of the normal curve. The lesser the value of the standard deviation, the smaller is the spread. Like here, in these figures A, B, and C, figure A has smaller spread. Now, so it has small standard deviation. B has the widest spread among the three, so this has a biggest standard deviation. And for letter C, it is medium in size, so it has a medium standard deviation. Okay, that is how we describe the shape, the normal curve, in terms of its corresponding standard deviation. Okay, A has a smallest standard A has the smallest standard deviation. B has the biggest, and C has the medium. So we'll talk of the properties of the standard deviation as of the normal curve. Okay, number 1, property. Okay, number 1, the total area under the normal curve is 1. Just like in the discrete probability distribution, wherein the total of the probabilities is 1. Number 2, its curve is bell-shaped. Number 3, its curve is asymptotic with the x-axis. Number 4, the distribution is unimodal. When we say unimodal, there is only one mode in the distribution. Number 5, it is symmetric about the y-axis. And number 6, its mean, median, and mode coincide at the center of the distribution. So these are the properties of the normal curve. Okay, like here, number 1 property is bell-shaped, so this one is bell-shaped. Number 2 property is its curve. That number 1 property is the total area under the normal curve is 1. So the area here under the normal curve, this region, is 1. Number 2, that the curve is bell-shaped. Number 3, its curve is asymptotic with the x-axis. So with y-axis, asymptotic with x-axis, this one. Okay, so this is the x-axis, and you know the asymptote, it approaches the x-axis but it does not touch. No, it just approaches but never touch. And number 4, the distribution is unimodal. Number 5, it is symmetric about the y-axis. So this is y-axis. So it forms a symmetry of 2 sections of the normal curve. It divides symmetrically. When we say symmetric, divide into equal parts. And one is the reflection of the other. Okay. So, and the last one is its mean, median, and mode coincide at the center of the distribution. So the mean, median, and mode coincide here at z equals 0 because the values here are z-scores. Okay. The values at the horizontal axis, this one, -3, -2, -1, 0, 1, 2, 3, are values of random variable z. That is the transform values of random variable x. The values of z are computed using the formula z is equal to x minus mu over O, where mu is the mean and O is the standard deviation. Okay, let's talk on area under the normal curve. Number 1, find the area below z is equals to -1. So find the area below z equals -1. So solution, let's draw a normal curve like this. Okay, locate z is equal to negative 1. Okay. Negative 1. Okay. Draw a vertical line at z is equal to negative 1. So it's here. Draw a vertical line and shade the region at the left until negative 1 as boundary. So shade this region. Okay. So that's how to draw a normal curve. At the z table, so you should have a z table. You will find that z equals negative 1 has an area of 0.1587. So this area, this value is taken from z table, which you should have upon discussion of the normal curve, and which means that it is 15.87% of the area of the total area of the normal curve. Okay, so that is how to get another example. Example number 2. Find the area above z equals negative 1. Okay. So again, draw a normal curve. This one. Locate z is equals to negative 1. It's here. Draw a vertical line at z equals negative 1. So draw a vertical line. And shade the region at the right starting negative 1 as boundary. So since it's above z equals negative 1, you shade this region because this is the area referred to in the problem. Okay. So from z table again, z is equals to negative 1 has an area of 0.1587. So since the total area of the under the normal curve is 1, so we're going to subtract the area here from 1 so that we get this area. Why we do this? Because in the area given by the z table is the area at the left of the location of the z value. So the area given in the z table is already the area at the left of the z value. So since the area of z equals negative 1 is here, and that is 0.1587, we just subtract this value of z equals negative 1, which is 0.1587 from 1, so that we get this area here. So subtract 1 minus 1.0000 minus 0.1587 equals 0.8413. So the area here is 0.8413 or 84.13% of the total area. Okay. Number 3. Let's have number 3. Number 3. Find the area between z is equal to 1.5 and z is equals to 1. Z equals negative 1.5 and Z is equals to 1. So, we're going to draw a normal curve. Locate Z is equals to negative 1.5 and draw a vertical line on it, no, at Z equals negative 1.5. So, here this is approximately 1.5, negative 1.5, and also locate Z is equal to 1. Shade the region making negative 1 between negative 1.5 and 1. So, after drawing a vertical line, so you shade this region, okay, as your indicator. That is the area which you are looking to. Okay, so after that, since the area from the table of negative 1.5 is here, Z is equals to 1 as an area from the table of 0.8413, and Z is equals to negative 1.5 as an area of 0.0658. So, 0.8413 minus 0.0658 equals 0.7755, or this area is 77.65% of the total area of the normal curve. Okay, so that is how to find the area of the normal curve between two values of Z. Okay, so let's talk more of Z score. Z score is also called as the standard score. It is not only applicable for normal distribution but also for any type of distributions, because it is already a standard score. Z score or standard score tells how many standard deviations a value of Z is away from the mean. A negative Z score tells that a value is below the mean, while the positive Z score tells that the value is above the mean. The Z score is unitless, thus even values of different units could be compared relative to their group, like in the following example. Okay. Number 1. The score of the students in the mid-year examination for mathematics has a mean mu of 32 and a standard deviation of 5. Find the z-score corresponding to each of the following. So we will find the z-score of letter A, 37, letter B, 22. Solution. We first lay out the given. So x equals 37, mu equals 32, that is given in the problem, and O is 5. So using the formula, z is equals to x minus mu over O. We have 37 minus 32 over 5 is 5 over 5 equals 1. So the z value of this score 37 is 1. Okay, so we're just getting the z, that is what is asked in the problem. So we'll no longer get the area under the normal curve at z is equals to 1. Letter B, x equals 22. This one, mu is 32, and O is 5. So, using the formula, z equals x minus mu over O, we have 22 minus 32 over 5, that is equals to negative 10 over 5 equals negative 2. So, the d value of the problem when the score is or the x is 22 is negative 2. So that is how to use the formula to get or to transform the value of x into z score. Okay. So let's go to the next example. The score of the group of students in the standardized test are normally distributed with a mean mu of 60 and the standard deviation O of 8. Answer the following. How many percent of the students got below 72%? Okay, solution. X equals 72, mu is 60, and O is 8. Okay, so make use of the formula z is equals to x minus mu over O, that is 72 minus 60 over 8 equals 12 over 8, or 12 divided by 8 is equals to 1.5. So, let's draw a normal curve. Okay. The normal curve is here. Okay. So, 1.5 is here. Now, approximately. Draw a vertical line on 1.5 z and shade the region at the left until 1.5 as boundary. So this one, okay, shade and go to the z table. Z equals 1.5 equals 0.9332 at the z table, or that is 93.32% of the entire area of the normal curve. So in the problem, okay, the students, the portion of the students that got below 72% is 93.32% of the group. Okay, so let's go to the next. What part of the group is scored between 58 and 76? Okay, solution. X equals 76, mu equals 60, O is 8. So, you make use of the formula x minus mu over O, that is 76 minus 60 over 8, that is equal to 16 over 8 or 2. Okay. So, it's just here. Another one is because we are getting the part of the group between scoring 58 and 76. So, we also get the area of the second one. No, this is number 2, not number 1. Number 2, x equals 58, mu is 60, O is 8. So, z equals 58 minus 60 over 8. That is negative 2 over 8 or negative 0.25. In the normal curve, we draw the normal curve, we draw z equals 2, draw vertical line at z equals -2, and locate z also equals -0.25, and draw also vertical line. Shade the region enclosed between z equals 2 and z equals -0.25 is here. Okay. Negative 0.25 is here, so draw a vertical line, and z equals 2, it's here, so draw a vertical lines, and after which you shade the region. Okay. Then find the area of z equals 2 at the z table, so that gives us, and also z equals -0.25. The z equals 2 from z table has an area, has a value of 0.9772, and z equals -0.25 at z table, it has an area of 0.4013. So this area here of z equals 2 is until here, but we are just going to find this area. So this area of z equals -0.25 should be subtracted from the total area of z equals 2. So that gives us this area between z equals -0.25 and z equals 2. So we subtract z equals 0.9772 minus 0.4013, that gives us 0.5759, or 57.59% of the total area under the normal curve. So that means what part of the group scored between 58 and 76. So the 57.59% of the group scored between 58 and 76. Okay, so the group is 57.59%. Okay. Next, if there were 250 students who took the test, about how many students scored higher than 64? Solution. X equals 64, mu is 60, and O is equals to 8. So the formula, X minus mu over 8, so over O, that is 64 minus 60 over 8 equals 4 over 8, that is 0.5. Okay, draw a normal curve again, locate z equals 0.5, and draw a vertical line at z equals 0.5. It's here, 0.5 here, and shade the region above z equals 0.5. So shade this region. This is the region referred to. Okay, so from z table, z equals 0.5 is has a value of 0.6915. So subtract 0.6915 from 1, because the total area of the region under the normal curve is 1. So that we can get this area above of z equals 0.5. So 1 minus 0.6915 equals 0.3085. So to get the total persons who got more than uh, who got more than 64, score more than 64, is we should multiply this the 0.3085 to 250 students who are taking the test. So the result is 77. So there are 77 students who scored higher than 64. Okay, that is how to get and make use of the formula. And this time we are using the Z table. Okay, so I am giving a test for you to answer. So this is test yourself. Letter A, okay. Letter A, determine the area below the following Z values. Number 1, Z equals negative 2.15. Number 2, Z equals negative 0.77. Number 3, Z equals 1.92. Number 4, Z equals 2.99. Number 5, Z equals 1.94. For letter B, we have determine the area above the following Z values. We have Z equals negative 1.15. Number 2, Z equals negative 2.07. Number 3, Z equals 1.90. Number 4, Z equals 1.39. Number 5, Z equals 1.44. Also, determine the area of the indicated region. So, the area between Z equals or Z is greater than negative 1.5 and less than 1.2. That means Z between the area between negative 1.5 and Z equals 1.2. Okay, so number 2 is Z is greater than negative 2.5 and Z is less than 1.0. Number 3, Z is greater than 0.5 and less than 2.2. And number 4, Z is greater than negative 0.8 and Z equals 2. And less than Z equals less than, and Z is less than 2.2, I mean. Number 5, Z is greater than negative 2.5 and less than 2.4. And after that, compute the corresponding Z-scores of the following X values given the mu equals 35 and O is 5. So number 1 is 40, number 2 is 30, number 3 is 38, number 4 33, number 5 34. Letter A, this is a word problem. A company pays its employees an average of 70 pesos okay, per hour. It's very small. 70 should be 200 per hour. 200 pesos per hour with standard deviation of 15 pesos. How many percent of the employees receive a salary less than 190 pesos per hour? And how many percent receive a salary of more than of more than 100, 105, 195. Okay, 195 pesos per hour. Okay, letter C, the 3% highest speed employees receive greater than what amount? So, answer this. You can comment down your answer on the comment section below to for your participation. Thank you very much and bye-bye.